Graphene and Fullerenes. So imagine we've got graphite, but imagine if we just take a single layer of graphite. That's what graphene is. Graphene is a single layer of graphite. That means it's got the same properties as graphite. It means it's really hard because it's made up of carbon atoms that are bonded together. And remember those hexagonal rings that are connected together. Also means it can conduct because it's got delocalized electrons. Remember, each carbon atom has 3 strong covalent bonds and 1 delocalized electron that could carry a charge through the structure or through the layer. That means it's really useful. It's useful in composites because it's hard and strong, and secondly it's good in electronics because as a single layer it's transparent, but also it conducts electricity. So fullerenes are this mystic arrangement of carbon atoms that you just got to get your head around. So fullerenes are molecules of carbon with hexagonal rings of 6 carbon atoms, although there are some rings that can form with 5 or 7 carbon atoms in them. The first fullerene discovered was called Buckminster fullerene. Buckminster fullerene has got the chemical formula C60. And the strange thing about Buckminster fullerene is it's spherical in shape. Insuring the old arrangement for a football in terms of the way it was patched together was based on Buckminster fullerene, where you had rings of 5 carbon atoms and rings of 6 carbon atoms forming this Buckminster fullerene spherical ball. So carbon nanotubes, they're cylindrical structures of fullerenes. So for instance, you'd have the same hexagonal rings of carbon atoms, but you'd have them around together forming a tube shape. So nanotubes, they have a really high length to volume ratio. This makes them really, really useful as building materials. We mix them with other things, we call them composites. So they're really useful in composites. And remember, they've got the same properties as graphite. So they're hard, they're strong, and they have delocalized electrons which can move through the substance. So they're really, really useful for electronics. They're also used for other materials, just to strengthen them. So you might have come across carbon fibre golf clubs or tennis rackets or different sporting equipment like that. Why? Well, carbon atoms are really light, so you're adding lightweight material, but you're also producing a really strong and hard material as well. So it's harder, stronger and more lightweight. Imagine how many uses there would be for a material like that.